Hello, class. So we are going to do the next section of notes in Module 4. And today we are going to be talking about what do we do or how do we describe data when we have two variables. One of them is categorical and one is numerical. So to summarize this type of data, we still want to show shape, center, and spread. So we visualize our data with the shape of the graph. We want to identify some sort of center, the mean or the median. And then we want to use some sort of numerical variable to show the spread of our data. And that's typically going to be standard deviation or interquartile range. When we calculate the statistics for center and spread, we almost always, keep mean with standard deviation or median with interquartile range. And when we're trying to decide which of those things to use, we do not mix and match them between the different categories of data. And then we do add one more thing, and that is a comparison between categories. Sorry if you guys can hear my dog in the background. So we have an example where we have 3 American beers that were compared for amount of alcohol by volume. So that information was all measured in a lab. And I have a much, much larger file with this beer data in it, but I've reduced it to just 3 different types of beers with the alcohol by volume for each of those different beers in those categories. So let's look at the data and pull it into R, and we'll answer these questions, and then we'll come back to the rest of our information. So we're going to want to know what our explanatory and response variable is. And I'm going to go ahead and open that Excel file so you can see it. I don't have it open already. There we go. That's beers. And so our beer data has alcohol by volume in the first column. That's called ABV. And then the beer style is our type of beer. We have the American IPA, the American Pale Ale, also known as APA here, and then the American Stout. And so we have our type of beer and the amount of alcohol by volume. And I think they were each measured at 12 ounces of beer, if I remember correctly. Um, so I do have my R file open, and you all have access to this one. It's that one cat and one num variable beer ABV R code. So the first thing we want to do is import our beer data. And I have some other data over here in my global environment, so I'm going to clear it out because I don't need that. So I use the broom. If you have any plots down here that you don't need right now, you may want to clear those out as well. I'm going to go to File and Import Data Set. You can also remember, go over here in your global and go to Import Data Set directly there. It is an Excel file, so I'm going to find it, browse, and then I'm going to open my folder that I have it in. I keep those Excel files all together, and it's the beers ABV Excel file. I am going to copy and paste that code. I hope so. So you can see we do have our ABV and our beer style here. I'm going to import the data, and I don't know if that actually copied. I'm going to try it. Yep, it sure did. So I'm going to go ahead and put that in there and save it. That way I can rerun it if I need to. So now we need to answer a couple of questions. Which variable is our explanatory variable and which variable is our response variable? So we have the amount of alcohol by volume and we have the type of beer. So our categorical variable is our explanatory variable. So that is beer style, and that is categorical or qualitative. And then which variable is the response variable? That's alcohol by volume, which is called ABV in the Excel file. It is numerical, and specifically, it is numerical and continuous because it's measured. So when we summarize this data, we want to summarize it using our comparative box plot. So a comparative box plot, you guys, is when we take all of the data and separate it by category, but make a box plot for each of those categories on the same axis. Um, so I think that you can see the graphs here. We have the American Stout, the American Pale Ale, and the IPA. We have alcohol by volume on the x-axis because I rotated it 90 degrees. Typically, your categorical variable would be on the x-axis here, but I like the way this one reads left to right with my box and whisker plots. The R code for these comparative box and whisker plots is to use the box plot function like we did in the last module, parentheses, and then you put in your data frame name. And for us, I do need to go and look at that actually. So the data frame name was beers ABV, and I'm going to look at my variable names while I'm at it. That's ABV and beer underscore style. So beers ABV, which was, I think, all caps. That's my data frame. Then I need a dollar sign. And remember when we're doing a box and whisker plot, it's that numerical variable we're using. So that's actually what goes first in this code. So we need our response variable, which is ABV. And then if we want to separate all of the alcohol by volumes by a certain beer style, we put in this new little thing called a tilde. So for those of you that took Spanish class, you know that's a tilde. Some of you guys are going to call that a squiggle. For all of you in your keyboard, that is in the top left of your keyboard, just next to the number 1. And then we put in the data frame name again. So beers, ABV, dollar sign, and then we do our categorical or our explanatory variable, which is beer style. And then I could just end parentheses. So I'm going to highlight what these things are. This is the data frame, dollar sign, response variable. Then I have the tilde or squiggle, whichever you prefer to call it. Then you have data frame again, dollar sign, and then you have your explanatory variable. And that explanatory variable is categorical, the response variable is numerical. So we can look at these graphs and we can compare this data pretty nicely. First of all, what I see is that the American Stout has a median that's a little bit higher than the American Pale Ale. The American Pale Ale, half the graph is like lower than the American Stout. When I look at the American IPA, it has the highest median of the 3 graphs, and it has a lot of outliers, but those outliers are on both ends. Also, when I look at these graphs, I notice that the American Stout's just a little bit skewed to the right. The American Pale Ale isn't really skewed to the right or left. It looks a little skewed to the left because of the long whisker. But when I look at both halves, it's not really. And then the American IPA is relatively symmetric. It's just that it has outliers on both ends. All right, so then we want to be able to do, remember, shape, center, spread, and comparison. So I typically put this in a box that looks like what you see on the screen, where I have the category, the center, the spread, and the shape all listed out. So my categories are stout, the American Pale Ale, which I'm just going to write APA, and then IPA for the third type of beer. And for the center, you guys, because we did have some outliers and a little bit of skewness, I'm going to use median for all of these. And I'm going to use IQR for all of these. Remember, we typically use the interquartile range when we use the median. And what we do want to do is if we use median for one, we want to use median for all. So the stout, let's look back real quick, was just a little bit skewed right with no outliers. The APA, which was the middle one, it's the green one, is a little bit skewed to the left, maybe not skewed to the left. I'm just going to say a little skewed. A little left skewed with no outliers. And then the last one was the IPA, which is the bottom graph. That's the red one, and it's really actually symmetric, but there are outliers on both ends. So it's symmetric, but lots of outliers on both ends. And then the last thing I want to do is a big old comparison. And that's what I have in this last box. But I'd like to go ahead and get those medians and IQRs before I do that. So I'd like to show you how to do that in R. I'm also going to show you how to get this comparative box and whisker plot. So I imported the data. And so now the first thing I want to do is create my side-by-side box and whisker plot. So let me flip my screen so I can do a little typing. And so to create your box and whisker plot, you guys, we already have the code. Um, the base box and whisker plot, you use the command boxplot, data frame $, numerical variable, tilde, data frame $, categorical variable. And so I just want to type that right now real quick so you can see it, see the base graph. So this is good, and you don't have to do this if you don't want. Boxplot, dollar parentheses, and then the data frame, which is beers, ABV, $, and then I want that numerical variable, which is ABV, tilde, again, top left of your keyboard, then data frame again, beers, ABV, $, and then I'm going to do the beer style, and I'm just going to run this code so you can see the base graph. So this is the base comparative box and whisker plot. Notice that the box and whisker plots are vertical and that the type of beer is on the x-axis. I prefer my box and whisker plots to be horizontal, so I'm going to rotate those. I'm going to make them colorful. I'm going to put titles on them and clean this graph up. And I've actually given you most of that code already. Some of the commands that you can use are here in the comment section. You can read that on your own. You will need some of these for homework, and not all of them did you learn in Module 3. So we have the code that we need to enter here pretty much. We need to put in the boxplot command in this next line of code. And then we need to do the data frame, which is beers, ABV, $. Remember, numerical variable always goes first here, then tilde. Then data frame again, and $, and then that categorical variable that you want. And then I need a comma here. It's not in my code. And then we have the main title. We have our Y label, which I just have as blank, so because I don't want one showing up there. Then we have X label, which is ABV. If I sometimes you need that beside equals true, you don't need it here. Last, um, remember we learned in the last module, same thing with sex axis. Par mar actually is used to move up portions of the graph to make like the bottom of your graph move up or the left side of your graph move to the right. And the instructions for that are above. And then horizontal, I want to turn it or rotate it. And then I'm using color rainbow 3 because we have 3 graphs and I want 3 different colors. So I'm going to run this code and hope it runs. There we go. And let's make sure I have a pretty graph. I'm going to zoom that so we can see it on the screen. And there's our beautiful graph, all nicely done. I could put in beer type for my X variable here, but I think if anybody's reading this graph, they would know the title's alcohol by volume, American Stout, Pale Ale, and IPA. I think that's pretty standard knowledge, sort of like heads and tails with coins. All right, so we got the graphs. Now what we have to do is get basic statistics. So historically, I taught 4 different ways to get the basic statistics, but I have learned that that actually confused students. And so this semester, I'm only going to teach one method in hopes that that will actually make it a little less confusing. So to do this method, though, we have to use a mini program that we have to go and get from the library. And we've already done this before where we used a library book called Read Excel to read in Excel data directly. So the one that we're going to be doing is called the Tidyverse. And some of you will already have the Tidyverse loaded, some of you will not. So let me show you how to get that library book. So to get that library book, next to the Plots tab in the bottom right function corner here, you go to the Packages tab. And I'm just going to start typing in the search command tidy. So Tidyverse should be checked if you already have it. And so I'm going to check that box if we want to run it. We haven't run it yet, so it wouldn't have been checked on mine. But some of you won't even have it visible here. And for those of you that don't have it visible, you have to go up to the top of the screen to the Tools package. So go to the Tools drop-down menu and then Install Packages. And then in Install Packages, start typing Tidyverse. So Tidyv and choose Tidyverse. And at this point in time, you're going to click the Install button. It will also install all other packages that go with it. So that install dependencies, you want to leave that box checked. Hit the install button and then follow the instructions if there are any. I'm not going to do it, you guys, because I already have Tidyverse on my computer. So I'm going to hit cancel. So now when we use the Tidyverse to make something like this table in our notes with the median and the interquartile range, we have to use it's called the dplyr function. And what we have to do is we have to type the data frame. Then we have to type this weird function. It's percent sign, arrow, percent sign. Then we want to group by our categorical variable. Then we do the percent, arrow, percent again. And then we summarize by whatever numerical thing we want. So if we want the mean of the numerical variable or the median, I always name those so that I can have a name of them showing up on the right. And this percent arrow percent thing, this weird thing here, is called a pipe. We are piping the data frame to the categorical variable that we're grouping by. Then we're piping that to the function in R that we want to use. So I've given you the base command down here to do this. Notice you'll see some asterisks. You have to get rid of those. And so what we need to do is put in the data frame. For us, that's beers, ABV. And then you have to type the pipe, which is percent, right arrow, percent. And I typically put a space in there. I think you can also do Control Shift M, Control Shift M. Nope, that didn't get it for me. Never mind. So percent, arrow, percent. So I am going to tell you, some of you are going to get errors here. And when you get these errors, you guys do not flip out. There are some weird packages that have to be loaded on certain computers. If you cannot get this code to run after you've typed everything, please come to office hours, shoot me an email, or shoot one of our TAs an email and meet with somebody before we come to class. All right, so data frame, pipe, then we need group by, and notice it's group underscore by. And then the categorical variable for us is beer style. And then the next thing I need is another pipe. So percent arrow percent. And then on the next line where I'm actually putting in my variables, I want summarize. So what I'm summarizing is the mean, the median, the standard deviation, and the interquartile range. And I want to point out that one of the things I did here was I pointed that to a named variable. That named variable is summary stats ABV, and I did that so I could print it out. Now, you guys, this is one line of code, beers ABV, down to the end of the name of this, summary stats ABV. But I cannot run this code without getting my tidyverse book from my library. So that's the first line of code I need to write, which is library, tidyverse. There you go. And that is one line of code. So I'm going to run both of these lines of code at once. I'm going to make my environment a little bit bigger so you can see all of this. And I'm hoping that I don't have any typos and that this will actually run. Oh, look at that. It did. Okay, so hopefully you've typed everything the way I did and didn't get any weird errors. If you got weird errors, please meet with me or a TA so we can help troubleshoot this. There are always issues with this particular section of the notes. Okay, so on the right, this gave us summary statistics for all of the beers, the mean, the median, the standard deviation, and the interquartile range, but that's very hard to read, so we want to actually print them out. And to do that, we just view the name of the variable we saved, and we print it, and it makes, first of all, graphs, but also look at the top. It automatically printed out this beautiful table, American IPA, the mean, the median, the standard deviation, the IQR. It did the same thing for the APA and the stout, and now I can just put all of these in the notes. All right, let me do that real quick. So the median for the stout was 0.0615. The median for the APA was 0.0565. The median for the IPA was 0.0680. The interquartile range for the stout was 0.0105. The IQR for the APA was 0.0130. And the IQR for the last one, 0.0070. And then we want to do our last comparison. I'm just going to do IPA has more alcohol by volume, so I'm going to call it ABV, than the others, comma, slightly. And less variability when looking at the middle 50%, or the IQR. And that's a good enough description of what we see here. You might write more, might write something a little bit different or be more detailed. But what you want is something about the shape of each graph. You want some sort of measure of center that is consistent across all of your categories, some sort of measure of spread that goes with that measure of center across all categories, and then an overall comparison of what you see in the graphs. All right, that's it, you guys.